All right, so in this video, we're going to talk about how we draw the electron configuration. If I don't know what the order of the shapes or the orbitals are, and how do I know how many are in each ring? Well, all of the messages are hidden in our handy dandy periodic table of the elements. So notice that every row tells me what ring I'm on. Right? So the first row, notice that they all start with 1. So we're always in the first ring or energy level if we're in row 1. Row 2 is our second ring or second energy level. Row 3 is the third, so on and so forth. And if you notice that there's different sections of the periodic table, so this section in blue, they're all moving in an S shape, right? This section in red, they're all moving in a D shape. This section in green, they're all moving in a P shape, right? So on and so forth. So what does this all mean and how do we use it to figure out the electron configuration or how the electrons move for nitrogen, right? So first thing you need to know is where nitrogen is on the periodic table. So nitrogen is the 7th atomic number. So it should be atom number 7, located right here. And if you recall from previous classes, that every time you move from one element to the other, right, going from element 1, hydrogen, to 2, helium, 3, lithium, 4, beryllium, you're just adding one extra proton. And assuming that these atoms are neutral, the number of protons equal the number of electrons. So you're also just adding one more electron as you're moving across the periodic table, right? So if I continually move across the periodic table, describing all the electrons for all of these elements until I reach nitrogen, right, I can describe the same thing. So when you're doing electron configuration, our starting points when we describe the electrons is always with hydrogen, right? So from here, we're starting with hydrogen. We're going to move across to get to nitrogen, right? So the first electrons from nitrogen will move in the first ring or energy level, right? And they will move in an S shape or the sphere shape. So 1s, right? How many electrons do I have here? Well, there are 7 electrons total, but I can also count the boxes to help me figure out how many electrons I have, right? So I have 1 element box, 2 element box. So in the first ring, I will have 2 electrons from nitrogen moving in the spherical shape in the first ring or energy level. Right, so let's move on and continue with the other electrons. So going across down to the next row, where will the third and fourth electron be? Well, here they're moving in the second ring in a spherical shape. So row 2 in an S shape, I have 2 electrons here. So 2s, 2. Then moving straight across, right, I reach boron, but when we get to boron, it's kind of hidden in here, but I'm still in the second ring, but starting from boron, they're going to move in this P shape. So I'm still in the second ring. We're starting to move in the P shape. How many electrons do I have moving in this P shape? Well, I have 1, 2, 3 electrons. So 3 electrons moving in the P shape in the second ring. So if I double check what I know about the Bohr model, and that is that nitrogen has 7 electrons, if I did everything correctly, and I count up all the exponent numbers, I should have 7 electrons as well. So 2 plus 2 is 4, 4 plus 3 is 7. So 7 electrons, that checks out, right? And if I drew the Bohr model, I would have 2 electrons in the first ring and 5 electrons in the second ring, right? But now we just have the addition of these letters to describe how the electrons are moving, right? So this would be our electron configuration for nitrogen. Let's work on another one. So let's do aluminum this time, right? Ooh, all my numbers are wrong. So for aluminum, if I look it up on the periodic table, it should be atom number 13. I'll be sure to change this after the video. All right, so we're looking at the 13th elements, which is right here. All right, and just like before, I'm going to start where hydrogen is and work my way across the periodic table in order to figure out the electron configuration up to aluminum. All right. So here for the first one, I'm starting at the first ring. They're moving in an S shape. There's 1, 2 electrons moving in this shape. All right, let me just color code it this time. Now I'm in the second row of the periodic table. So I'm in the second ring. I'm in the S section. So 2s, and there are 1, 2 electrons moving in this shape. So 1s, 2. Right. Then going through here, I'm in the P section now, still in the second ring. So in the second ring, I have electrons moving in the P shape, and I have 1, 2, 3, 4, 5, 6 electrons moving in this shape. 2p6. Right. And if I were to continue on the third row, here I have electrons moving in the third ring in the S shape, and there are 2 of them. So 3 in this yellow box, 3s, moving in that S shape, and I have 1, 2 electrons here. Right. Now I get to aluminum. So I'm almost done. So here I have 3p. So I'm still in the third ring. This electron's moving in the P shape, and I have 1 electron moving in this shape. So 3p1. So if I double check, my exponent should add up to 13. So 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 1 is 13. So I have 13 electrons. And if I drew out the Bohr model, I should see 3 rings where the first ring fits 2 electrons, the second ring or energy level fits 8, and the third ring fits 3. Now, if you noticed, when we did this, it kind of took a long time, and it took a while to write all of this out. So there's a different way we can write things, and that's called shorthand notation. So when we're writing shorthand notation, we can skip some steps. Right, so let me do this problem again and show you how we would write it if we want to write a shortened version of the same thing. So if we were to write the shortened version of the same thing, aluminum is element 13, the mass is not this, right? Okay, so if we were to write the shortened version, rather than starting at hydrogen every single time, we can start at any one of the noble gases before aluminum, right? So here, if I work backwards up the row, I would start at neon because it's the closest in group 8, also known as the noble gases, that comes before aluminum, right? So I would write Ne for neon in brackets. Moving straight across. So here's my starting point now. I am in the third ring, S. It's moving in an S shape. 1, 2 electrons. So 3s, 2. Right? And then on here, when I get to aluminum, I'm in the third ring still. So 3p. How many electrons do I have? Well, I have one element box, so 1 electron. Right? So I can also write it like this. This is just a shorter and faster way of writing or describing the electrons, because mainly the electrons that matter the most are the electrons in the outermost ring. Right? And we'll talk about that why when we talk about the periodic table.